Hey, Alex, Miss Power here to go over the group quiz review. We did this on Friday, on the 4th. We are going to test on the physics 7th. It'll be the group quiz on Monday, all period long. Here is the review, done out in full, explained totally. I'll try to go slow. I know people say I talk too fast on these things, and I agree. Okay. The first step is solving for x. I should have said solve for the variable because the first one's b, not x. But we are going to, there's a couple of different ways to do these. I saw a lot of people in class find common denominator. So we can make this 15 over 20 by multiplying both the top and the bottom by 5. And then saying that b plus 3 has to be 15. So that makes b 12 because 12 plus 3 is 15. That's a really good way to do this. You can also go like the more systematic way. You can do cross multiplication. So the blue is a different way to do this problem. You don't have to do both ways. Cross multiplication is when I say 3 times 20 is equal to 4 times b plus 3. 3 times 20 is 60. 4 times b is 4b. 4 times 3 is 12. I subtract 12 on both sides to get 48. And then these cancel. Then to get b by itself, I would divide by 4 and get 12. So that's also a totally valid way to do this. For part B, I am going to go straight into cross multiplication. The x times the x gives us x squared. The 3 times x plus 6 gives us 3x plus 18. Right, because I'm going to do the 3 times the x and times the 6. Now, over here we've got a linear equation. That means there's only x's and numbers. Over here, we've got a quadratic equation. We've got x's, numbers, and x squareds. We've got a quadratic equation. We want to move everything to one side, and we want the x squared to be positive. It just makes it easier. Then we're going to factor. We're going to think of numbers that multiply to negative 18 and add to negative 3. We're going to end up with negative 6 and 3. And then our final answer, that's the worst curly brace I've ever drawn on my life. The final answer, we're going to switch the signs of those. Cool. This is some practice we're going to do because we're going to use the cross multiplication throughout this worksheet, right, throughout the review. Okay. Oh, no. It's not letting me scroll down. Yes, it is. Nice. Cool. I do not like computers. Anyways, part 2 is writing a similarity statement for two triangles here that are similar, and then using proportions to find the unknown values. For here, the two triangles we have that are similar are this green one up top and this light green one down bottom, right? I'm going to rewrite these off to the side because I'm obsessed with doing that. I think I'm a lot smarter when I look at stuff like this rather than complicated diagrams like this. For the light green one, I've got S, R, and F. For the dark green one, I want to know what angle is equal to this angle R. Turns out that it's the angle G because of alternate interior angles. So alternate interior angles give us that O and F are equal, as well as G and R. And then we can say the triangles are similar by AA. We could have also said vertical angles give us these ones. And vertical. Now, when I say which one matches with S, which dark green triangle vertex matches with the vertex S on the light green triangle, it's also S because it's the same angle. G matches with R, so I'm going to write it in the corresponding place to R. And O matches with F. The triangle congruency is then SRF and SGO, making sure that if R matches with G, they're in the same place. Okay, now I can fill in my sides. For this one, it's 90, 70, and S. Between G and S was 36, between G and O was 48, and between S and O was T. And now I'm going to set up proportions to solve for the missing values. I can either do proportions, so I can do like 90 divided by S equals 36 divided by 48, because these two sides match up with these two sides, since we've got similar triangles. Then I can cross multiply, and I probably should have a calculator out to do this. I'll use my phone. I can say 90 times 48 equals 36 times S. 90 times, that's 91. 90 times 48 is 4,320. And then I'll divide by 36. Divided by 36 is S is 120. So this is how I would do it, the proportions, if I wanted to say these two sides are proportional to these two sides. I can also do scale factor. A lot of people like to do scale factor. So if I start with 90 and go to 36, turns out I divided by 2.5. I got this number because I did 90 divided by 36. Got 2.5. So I would also want to divide 70 by 2.5 to get T. Right? The scale factor would be the same, so 70 divided by 2.5 is 28. Either way, either method works. You could do the first method for both of these, the second method for both of these. It's totally fine. On. For this diagram, nice, got there. These angles are equal, and these angles are equal because they are all corresponding angles. And then once we've got two angles in each triangle, we can say they're similar by the angle-angle theorem. Nice. Which triangles are even equal? We've got EFT. We've got ELA. That one's really hard to see. I'm going to write it in regular green. And we've got EGR. Nice. Because the numbers and the missing variables we're dealing with are all on the sides. There's nothing straight down the middle. There's nothing hitting the parallel lines. Because they're all on the sides, we can just do it part by part, right? We can say from 21 to 42 was times by 2. So from 35 to x will also be times by 2, meaning x is 70. That's how to do it the scale factor way. If we wanted to do it the proportion way, we would say 21 over 42, so the left over the right, is equal to 28 over y. This left over this right. We cross multiply. This is 21y equals 28 times 42. We could say 28 times 42 is, oh my gosh, where's my math? 1176. We would divide that by 21 and get 56. Pretty good. So again, we can do these with proportions. We can do these with scale factors. It's all the same stuff, right? It's just different ways to visualize it. For these both, I do want you to say more than just angle for the reason, right? I want you to say, how did we know these angles? We knew them because these were vertical and alternate interior, and we knew these ones because they were corresponding. I am looking for that on the quiz. Okay, on to page 2. Based on parallel lines and similar triangles, write and solve a proportion to find the unknown value. Okay, A is kind of like the one we just did, right? All of our stuff is on the sides, so we can just say 7 divided by 9 is equal to 5 divided by question mark. So right, this one over this one equals to this one over this one, or left over right equals left over right. If we solve this, we get 7 times question mark equals 9 times 5, which is 45. If we divide both sides by 7, we get our missing value is like 6.4-ish. Nice. So we could have done this proportion, which was left over right equals left over right. We could have also done left over left equals right over right, right? We could have also done 7 over 5 equals 9 over question mark. Will this get us the same answer? Of course. When we cross multiply here, we got 7 times question mark equals 9 times 5. When we cross multiply here, we also get 7 times question mark equals 9 times 5. So we should expect the same answer because we had the same equation. What I want right here is whatever proportion you used. I'll use 7 over 9 equals 5 over question mark. All right. For this one, a little bit different. We do have missing values and numbers right down the middle of this on the parallel lines. It's not just on the two sides. So for this one, we're going to have to write two triangles. We're going to have to say this maroon part, this question mark over 12, and this part, 10 over this entire side, are what we're going to compare. This entire side is 16 because we did 12 plus 4. We added these two sides together. Right? So now we want to write the proportion. We can either write question mark over 10 equals 12 over 16, because we've got these two sides divided by each other are going to be these two sides divided by each other. The small base over the big base, the small left-hand side over the big left-hand side. Or we can do the small triangle equaling the big triangle, right? So the base of the small times or divided by the left of the small equals the base of the big divided by the left of the big. Great. Both of these will give you the same thing when we cross multiply, which is 16 times question mark equals 120, because it's 12 times 10. 12 times 10 over here and 12 times 10 over here. So then this is just 120 divided by 16, which is a number. Let's see what that number is. 7.5. Again, the thing we want right here is just what did you write? What was your group's proportion? All right, run it back. This one, they're both on the sides, so I can just do part by part. I'll do 3 over x equals 2.5 over 7.5. When I cross multiply, I get 3 times 7.5 equals 2.5 times x. Get my calculator out. 3 times 7.5 is 22.5. Dividing both sides by 2.5 gives me x equals 9. Could we do this with a scale factor? Yes, of course. We could say to go from 2.5 to 3 was multiplying times 1.2, and 7.5 times 1.2 was 9. Totally fine. Totally fine. Over here, this one we're going to have to do the triangle thing. We're going to have to say, here's one triangle, here's another. We're looking for this side, and this side is 20, because it's 8 plus 12. So my setup that I like is 5 divided by 8 equals question mark over 20. You could have said also 5 divided by question mark equals 8 over 20. That's totally fine as well. Both of them give you the algebra sentence 5 times 20 equals question mark times 8. So we've got 100 equals 8 times question mark. We're going to divide by 8 and get 12.5. And again, this one would give you the same thing. It's still 8 times question mark, and it's still 5 times 20. Whichever makes more sense to you, do it. Here's another triangle one. I'm going to say 14 over x equals 20 over 50. I'm going to say 50 because this side, when I add it up, becomes 50. Cross multiply. Get 50 times 14 equals 20x. 50 times 14 is 700. Divide both sides by 20. We get 35. Is that true? It is true. Nice. So we get 35 here. And then over here, I could use scale factor. I could say 4 times 1.0. Oh my gosh, I'm not going to use scale factor for this one. I could, right? I could say 4 times 1.5 is 6. I was so excited because I know that one. And then I could say, okay, x minus 2 times 1.5 is x. So over here, I could say x minus 2 times 1.5 equals x. That's a little bit silly. Of course, we're allowed to do it. We could add 3 to both sides, subtract x from both sides, divide by 0.5. I don't even know if that's true. Maybe it is. Let's check over here. The much more regular way to do this one is to say x divided by 6 equals x minus 2 over 4. Cross multiply. Get 4x equals 6x minus 12, because 6 times x is 6x, and 6 times negative 2 is negative 12. I'm going to subtract 6 from both sides. Get negative 2x is negative 12. Divide by negative 2 on both sides, and get x is 6. So I guess I was right over here. But again, the much more normal way to do this would be to set up the proportion x over 6 and x minus 2 over 4. Nice. On to the third page, onto the word problem. Georgie, this person, is trying to figure out how tall a tree is that he planted last year so we can calculate how much it grew. It was 2.5 feet when he planted it. So he planted it like here. Nice. He learned in math class that he can use shadows and similar triangles to calculate the height of things. Find the height of the tree. If he's 5 feet tall and he cast a 7-foot shadow, the tree is x feet tall, casting a 14-foot shadow. If the shadow for the tree is twice as long as the man, oh my god. No, none of that is what I want. That's a shame. Okay, if the shadow of the tree is twice as long as the shadow of the man, then the height of the tree is also going to be twice as long as the height of the man. So basically the scale factor here is 2, so the scale factor here will also be 2. Is 10 my answer? No, because the question was, how much did the tree grow? Right? If it started at 2.5 and ended at 10, we would subtract those, and the amount that it grew is 7.5. So that would be my answer. Make sure to watch out for tricks like that on the quiz. I won't feel bad. Cool, but we'll use similar triangles. We also could have said, 5 over x is 7 over 14, cross multiplied, and got this. Second to last one, find the measures of x and y. Oh, this is y'all's favorite, because what we're going to do is we're going to make 3 triangles. Right? We're going to say this big triangle, the entire thing, we can write over here. This medium triangle, we can write over here. And this smallest triangle, we can write over here. I am going to draw them all facing the same way, in the same orientation, right? The entire point of me disaggregating these triangles, like spreading apart these triangles, is so that I can see them better and can compare them easily. So I definitely want them all facing the same way. I want them all like in order. The way I'm going to do that is I'm going to label this A angle as a green with 1 tick mark. So green with 1 tick mark. And then I'm going to label this B angle as 2 arcs. And I'm going to make it blue, right? I'm going to decide that blue should be up here. This is completely arbitrary. You could have picked the other one. I don't care. And green should be down here. And now we're going to enter all the side lengths. Every time I see a 15, a 20, a y, and x. So this one's y. This one's x. This one's 20. This one's 15, which makes this entire side 35. On the red triangle, y is across from this double blue angle. So I'll put it across from the double blue angle. X is across from the green angle. And 35 is the other one. Nice. In the orange triangle, I only have 20 and x. 20 is next to the blue angle, but on one of the legs. So the 20 should go here. X is the longest side, so I'll put x here. And then I don't have this triangle right here, triangle side, so I'm just going to ignore it for now. The light blue has y and 15. Y is the longest side, is across from this right angle, so I'll put it on the longest side. And then 15 is right next to the green angle, so I'll write it right next to the green angle. Save. Nice. Now I want to solve for either y or x. Pick your favorite one. I like x better. I'm going to solve for x. The way I'm going to solve for x is I'm going to try to make an equation that involves only x's and numbers. So any proportion that I can set up that involves only x's and numbers is what I want. I can see that the hypotenuse and the right-hand side of the red triangle and the hypotenuse and the right-hand side of the orange triangle are 35, x, and 20, which are only x's and numbers. So I'm going to say 35 divided by x equals x divided by 20. 35 over x equals x over 20. And again, that's these two sides of these two triangles. Nice. Now I can cross multiply. I can cross multiply. I get 35 times 2 times 20 is 700. X times x is x squared. To get x by itself, I'm going to square root both sides and get like 26.5 about. Nice. So x is 26.5. If I want to solve for y, I can either do the same thing, but with 35y and y and 15. Right, so I can come over here, do 35 divided by y equals y over 15. I can do some math, right? I can figure out that, I'll just actually do it, actually. 35 times 15 equals y squared. 35 times 15 is 525. If I square root both sides there, I have to unlock my phone. Yep, let's go. The square root of 525 is 22.9. To be honest though, once I figured out that x was 26.5, I could have looked at this triangle and done the Pythagorean theorem, right? I could have said y squared plus 26.5 squared equals 35 squared, which means y squared equals y squared plus 700 equals 35 squared. So 1225. I then could have subtracted 700 from both sides, gotten that y squared was 525, square rooted both sides, and got 22.9. Pretty good. Same. By the way, what you're going to want to do first is draw these three triangles. I'm not kidding. Like, it's just, I keep saying it, and I feel like people don't do it, and it is just easily the best way to do this. Last one. M is the midpoint of AB. Let's find these two values. We're going to do the x's in one step and the y's in a totally different step. So let's do the x's first. We want to say that the middle of -5 and 27 is A. Let's find the middle of these two numbers. The middle of -5 and 27 is, I'm going to say 27 plus -5 divided by 2. That's 22 over 2, which is 11. Pretty good. A lot of other people say that from 5 to 27 is 32. It's 32 units away, which is true. 27 minus a -5 is 32. Cutting 32 in half gives us 16 and 16, which is also true. And then A is just -5 plus 16, or 27 minus 16. That's also a fair way to do this. You don't have to do both ways. You can just do one of them if you want. To do this one, to solve for B, we're going to say that 13.5 is the middle between 76 and B. We can figure out how far away these ones are by doing 76 minus 13.5, getting 62.5. These ones are also 62.5 away because it's in the middle. So I'll do 13.5 minus 62.5 and get -49. There are, of course, other ways you could do this as well, but that's probably the fastest. Now that's the review. If you have questions, you can email me. I might not email you back until later. Right? Hopefully this review makes sense. Feel free to text your classmates. Feel free to study with your friends, study with your group mates, and I will see you on Monday for the group test.